Alrighty, so now that we've learned how to determine whether two functions are inverses of each other, now we're going to find the inverses of functions. So for our first example, we're given f of x equals 4x plus 6, and we're told to find the inverse of f of x. So how do we do that? Let's go to the step right here. It says going to finding an equation of an inverse of a function. So I said for a one-to-one function defined by y equals box of x. Why did I put box of x? Because it can be f of x, g of x, h of x, k of x, anything, right? Just a function. The equation of the inverse can be found as follows. So our first step, we want to place the box of x by y. So in this case, our box of x is f of x. We want to change that to y. So step 1, okay, this is y is equal to 4x plus 6, right? Now we're going to interchange x and y. So if I see a y, it's going to become an x, and if I see an x, it's going to become a y, right? And then step 3, let's solve for y. So what I'm going to do, so since it's positive right here, I'm going to subtract 6 over. So I'm going to rewrite this as like 4y is equal to x minus 6, right? So what did I do? So if I do that, then look over here real second. So if I subtract 6 over, this is x minus 6 equals 4y. What I did in this next step is I just switched these. All right, you can go ahead and do that right away. It doesn't matter. Okay, so remember when we solve for y, we want the coefficient to equal 1. So in order to do that, I have to multiply or divide everything by 4. So I have x minus 6 over 4. Okay, so remember, I cannot reduce 6 and 4. Why? Because they're terms, right? They're not factors. X minus 6 is a factor, and then over here, 4 is a factor, all right? But 6 alone, it is a term. Okay, terms can't cancel anything out by multiplication or division, right? So our very last step, so we're saying y is equal to this, but we've already established like this is f of x, so f of x is essentially y. We can't have y equals 4x plus 6 and y equals x minus 6 over 4, okay? Can't happen. So what do? So what was essentially our instructions? Our instructions were to find the inverse. So we have to replace y. So y is f inverse of x. Right? So this is our inverse of f of x. Right? So what do we want to do? So if we're not entirely comfortable, if we're not 100% sure if we found the correct inverse, what can we do? Luckily, we have tools. So the tool that we learned from the very first section is determining whether or not they are inverses of each other. So how do we do that? We have to prove that f of g is equal to x and g of f is equal to x. Oops. Right? So again, this is an extra credit opportunity. Okay. I'll do 1 point. Okay, and this is due 4-22 at 11:59. And just turn it in at the extra credit, right? But what I want you to do is I want you to prove to me, okay? So show their inverses of each other. Okay, so use the step that we learned in the first section to show me this. All right? So now let's move on to example 2. Okay, example 2 is states the one-to-one functions g and h are defined as follows. So we're given g of x is equal to x plus 3 over 7, and then we're given h is equal to all of that. I'm not going to rewrite it. I'll refer to it when we get to that piece of the problem, right? So first of all, we want to find, and I'll just call this A. So we want to find G inverse of X. So again, how do we find the inverse? So first, colon. So we know that G of X is equal to X plus 3 over 7. Now what we're going to do is, so G of X, we're going to replace this with Y. And then what do we do now? We're going to interchange X and Y. So wherever I see a Y, I'm going to plug in X, and wherever I see an X, I'm going to plug in a Y. Okay, now we're going to solve for Y. So I'm going to multiply both sides by 7. When I do that, I get 7X equals Y plus 3. Subtract 3 from both sides. Then we get 7X minus 3 equals Y. I'm going to rewrite it. Let me write it down here, okay, just so I can have it on the left side, because that's what I prefer. Right? And then lastly, okay, don't forget what we're doing here. We're finding the inverse. So our very last step, now that we've solved for Y, is now we're going to replace this as G inverse of X. Okay, and that is our answer for the first part. Okay, for the second part, I'm going to put it on the right here, and I'll call it B. So now I want to find G of G inverse of 1. All right? So let's go ahead and just find G. Let's find G of G inverse, and then I'm going to find G of G inverse of X first. All right? So what is G? Oops. Okay, so G of G inverse of X, what is that? That's G of G inverse of X. Okay? And when I do that, so this is G of, and then G inverse of X is 7X minus 3. And then this is, this would be 7X minus 3 plus 3 over 7. Okay, so this becomes 7X over 7. This is equal to X, right? So this shouldn't be a surprising result. Why? Because we know G and G inverse are inverses of each other. And what does the property tell us? It tells us if they're inverses of each other, so G and G inverse are inverses of each other, it means that G of G inverse of X is equal to G inverse of G of X, and they equal X, right? Always. Okay? So if they are inverses, if you know for a fact that they are inverses, they will, if you take the composition of them, they will always equal X. So what am I trying to get out here? So the reason why I did all this work, the reason why I didn't solve for G of G inverse of 1 is that if you conceptually know that when you have two inverses and you compose them with each other and you get X, what does that mean? That means that no matter what is over here, that's your answer. Okay? So let me do another color so it can just distinct. So if I ask you, what is G of G inverse of T? That is T. If I ask you, what is G inverse of G of 25? Your answer will be 25. If it's G of G inverse of X squared, this will become X squared. Okay? If you have the function and you know that they are inverses of each other, whatever is in here, that will be your answer. Because if you know this, so because G inverse of G of X, we know is equal to X. And so over here, you just plug in that value, and when you plug it in, you just get what you put in, right? So if you put 25 into X, it's still 25. You put T into X, okay? Even if you I don't know, maybe even G inverse. If I have G inverse of G, and then I don't know, negative 1,000. What are we going to get? Negative 1,000. Oops, oh my goodness. Right? So that's the biggest thing about B, is that when you know two functions are inverses, okay, G of G inverse of G, you always get X. So when we're asked this type of question right here, you can just tell me the value in here, right? You don't have to actually solve G of G inverse unless it says to verify, right? But this will save, knowing the concept behind this will save you a lot of work, right? It saves, like, for example, look at all this. This is like, what, 5 lines? We can reduce it down to 1, which is always nice, right? So now let's do the last part in our section. I'm just going to make this bigger here. Oh, my goodness. All right, it's right here, right? So we want to find H inverse of 6. So recall, let's go back up here. I'm going to make this a little smaller because it's ginormous. What do we know? We know that the domain of F is the same as the range of F inverse, and we know the range of F is the domain of F inverse. So, okay, so if I ask you, so when I ask you, like G of 1, what are you going to do? You're going to plug in, wherever you see an X, you're going to plug in the 1, and then you're going to solve for G of X, which is essentially our Y. When I find H inverse of 6, okay, so, okay, before we do this, let's take a step back. Let me erase this real fast. If I asked you, okay, if I asked you, what is H of 0? Okay, and you're given this. What are you going to do? You're going to look, when is our X 0? And you're going to give me this Y, right? If I had asked you, what is H of negative 4? You're going to find when X is negative 4, and you're going to give me the Y coordinate, right? So now, what is the difference? The difference here is I'm asking you, what is H inverse of 6? So, and because we know that the domain of our function is the same as the range of our inverse function, this tells me when I'm asked what is H inverse of 6, this tells me, let me erase this, make it a little more clear. Okay, maybe make it a little bigger, right? So now for H inverse of 6, we're looking at Y values. Okay, and then we're going to spit out its X value, right? So I'm going to look here, and I'm going to look, when is my Y 6? My Y is 6 right here. So what is H inverse of 6? H inverse of 6 is 5. All right, so let's do another one. If I had asked you, what is H inverse of, I don't know, 4? Okay, what we're going to do is we're going to look, when is our Y4, which is right here, and we're going to spit out its X value, okay, because there's an inverse. If I just ask you what is H of negative 4, it's 5, right, from right here, okay. So let's just do one more just to, just to be safe, right? If I ask you, what is H inverse of 3? Okay, what do we get? Actually, you know what? I'll make this an extra credit problem. I want you to find what is H inverse of 3, what is H inverse of 5, and what is H inverse of negative 2. Okay, this is extra credit. Okay, also due 4-22 at 11:59 p.m. Right, this is worth 1 point. Right, so that is the end of the second topic, and then next we'll go on to topic 3.